to the first 9 weeks just-in-time video for geometry. In this 9 weeks, we will explore and investigate the rectangular coordinate system, how shapes are constructed, and the rigid motions on a coordinate plane. Our first module is called Reasoning with Shapes. This module consists of 23 A and 23 B days, or 46 double block days. Let's look a little more closely at some of the specifics for Module 1. Module 1, Reasoning with Shapes, consists of 3 topics: using a rectangular coordinate system, rigid motions on a plane, and congruence through transformations. Topic 1, Using a rectangular coordinate system. This topic consists of 5 lessons. Lesson 1, The Squariest Square, from informal to formal geometric thinking. In this lesson, students will recall properties of geometric figures. They will then understand that the results of measuring tools can be useful in composing a conjecture. However, they are not an acceptable form of mathematical reasoning to validate the conjectures. Lastly, they will make geometric conjectures and use mathematical reasoning to validate it. Lesson 2, Hip to be a Square, constructing a coordinate plane. Before we delve into the specifics of this lesson, here are the key terms for the lesson. Our first exploration is constructing a perpendicular line segment and bisector using paper folding and using a compass and straight edge. They will then use construction tools to duplicate a line segment and construct a square. From here, we will use constructions and rigid motions to create a coordinate plane. They will then identify rigid motions that can be used to create shapes on that coordinate plane. Lastly, students will identify the coordinates of vertices of shapes on this coordinate plane. Lesson 3, T's and train tracks, parallel and perpendicular lines. Now that students have constructed line segments, perpendicular lines, squares, and a coordinate plane, we're going to look at how we construct parallel lines, identify and write the equations of lines perpendicular to given lines, and finally, identify and write the equations of parallel lines, including horizontal and vertical lines. Lesson 4, Where has Polly gone? Classifying shapes on the coordinate plane. In this lesson, we will explore the distance formula using the Pythagorean theorem. Students will apply that distance formula to points on the coordinate plane. They will then classify triangles given the location of vertices on the coordinate plane. Once students know how to find vertices on the coordinate plane, they will determine coordinates of a 4th vertex. Finally, they will classify quadrilaterals given the locations of its 4 vertices on the coordinate plane. Lesson 5, In and Out and All About, Area and perimeter on the coordinate plane. In this lesson, students calculate the perimeter and area of rectangles and triangles on the coordinate plane. They double dimensions of figures and explain how this affects the area of the figure. They also translate figures on the coordinate plane to more efficiently determine their perimeter and area. Students algebraically determine the non-vertical height of a triangle as they treat each side as the base. They then use the height to calculate the area of the triangle. They conclude that the area of a triangle remains the same, regardless of the side considered as the base and the height determined by that base. Next, students divide a composite figure into various known polygons to compute its areas. They then consider real-world situations requiring them to calculate the perimeter and area of polygons that lie on a coordinate plane using distance formula and decomposing the polygons into triangles and rectangles. Students will determine distances represented as the area under the curve of velocity-time graphs. They investigate how proportional and non-proportional changes in the linear dimensions of a shape affect its perimeter and area. Finally, students develop a strategy for calculating areas of regular polygons. Our pacing guide recommends to have the end of topic assessment here, over topic 1, using a rectangular coordinate system. If we navigate to the Clear Learning Center, we find the end of topic assessment in 2 formats: the online digital platform and the printable paper-based. In the online interactive form of this assessment, students are presented with multiple types of questions that include multiple choice, short response, and numerical. Topic 2, Rigid Motions on a Plane. This topic is comprised of 6 lessons. Lesson 1, Put your input in, take your output out. Geometric components of rigid motions. In this lesson, students will get the formal, precise definitions of line segment, angle, and distance along a line. They will then translate lines to produce parallel lines. Misconception alert. When discussing rotation, it may not be intuitive that positive rotation angles turn counterclockwise and negative rotation angles turn clockwise. To mitigate this, you can show a positive direction moving up and around, and a negative direction going down and around. Lesson 2, Bow Tie. Translations as functions. Here, students will explore translations on the plane. They will describe translations as functions that take points on the plane as inputs and produce translated points as outputs. Finally, students will compare transformations that preserve distance and angles, called isometries, to transformations which are not isometries. Topic 3, Staring Back at Me, Reflections as Functions. This is where students will investigate reflections in the plane using patty paper and constructions. They will then describe reflection transformations as functions that take points as inputs and output reflected points. They will then identify reflections as points equidistant to the perpendicular bisector of line segments connecting the pre-image and image points of the reflection. This lesson ends with students specifying a sequence of translations and reflections that will carry a figure onto a congruent figure. Lesson 4, Turn Yourself Around, Rotations as Functions. In this lesson, students will investigate rotations in the plane. They will describe rotation transformations as functions that take points as input and output rotated points. They will finally end with specifying a sequence of translations, reflections, and rotations that will carry a figure onto a congruent figure. Lesson 5, Slide, Flip, Turn, the latest dance craze? Translations, rotations, and reflections on the coordinate plane. Students have learned that translations, reflections, and rotations behave like functions. They will use these rules to translate geometric figures, rotate geometric figures, and reflect geometric figures on a coordinate plane. Lesson 6, Oki-Chiobi, Reflectional and Rotational Symmetry. Now that students have learned that pre-images are congruent to images after rigid transformations, they will investigate line symmetry and rotational symmetry. They will then identify lines of symmetry for different geometric figures, describe rotations that carry a figure onto itself, and lastly, describe reflections that carry a figure onto itself. Let's take a quick glance of this 9 weeks CVA. This assessment will consist of 11 one-point questions and 1 two-point question, for a total of 12 questions. We see here that the items chosen for this assessment are all from Module 1, Topic 1, with the readiness and supporting standards noted here. This concludes our first just-in-time video for geometry. We hope you found this video helpful and have a great first 9 weeks.